Okay, let's open the project that we've been using, which is that one, classifiers. Okay, so now we have, okay, let's go ahead and create a new diagram, and we'll call it Ch09-DT for decision tree. Okay. And we're going to create a new data source, which is our universal bank. And we already have the library from the project. So select universal bank. Okay. So let's use the advanced metadata advisor. So okay, we've gone through this before, so let's just accept the defaults. Okay, now let's review this. Age is interval, CC average interval, CD account, binary, this is binary, that's good. Education is nominal, but let's change that to ordinal because it's 1, 2, 3 high school, college, and so on. Experience, okay, right. Family, I don't know whether that is, should be nominal or ordinal. I think it is the number of people, so we can use nominal, ordinal for this as well. So this is important here. In other methodologies, the differentiation between nominal and ordinal may not matter that much. But here it matters because what? If it is ordinal, you have to make sure that the splits occur in a way that is not inconsistent with the values. So you can't have number 2 on the left side and number 1 on the right side for an ordinal case. So that's why it's important in this methodology to differentiate between nominal and ordinal properly. In other methods, it may not be that important. Okay, so ID, income, mortgage, say online is binary, personal loan is binary, securities account is binary, zip code is rejected, which is okay. Now personal loan is the target. Okay, because we want to see which customers will accept an offer for personal loan. So that's the objective. Okay, so now we can set up a decision processing here, okay, if you want, like what is the benefit of correctly identifying an event, and then what is the cost of, false positive. Benefit of true positive, cost of false positive. So those numbers can be entered here. We'll look at an example a little later. Right now, let's look at decision tree. Okay, so now we have the data source set up. So bring the data source in. Okay. Next, we're going to set up a data partition, and let's do 60/40. Or let's look at an example which includes test also. Okay. So here, let's see what I have used. So 50, 40, 10. So let's do that. 50% training, 40% validation, 10% test. Now, test is important when validation data set is also used in developing the model. Okay, so if the model development does not involve validation at all, then only training is used for developing the model, then validation set will be useful in ascertaining or computing how effective the model is for performance. But sometimes you may have to use the validation set itself in the process of modeling, which in this case is true. In decision tree, you look at the validation set to determine which way to go. So in cases, okay, which way to split. So in cases like that, it's a good idea to have a third set for computing the performance measures. So which is what we're going to do here. So we are splitting this with as 50, 40, and 10. Okay. Then we bring in decision tree, which is a 10. So bring that in. So connect. So let's align it. Okay. Now let's go through the parameters in just a little bit, but let's go ahead and run this and then see what we get. Okay. Let's look at the results. Okay. So we have lots of statistics here. What we want to look at is that one. So here is our tree. Okay. If you want to look at the entire tree, you can right click and then select fit to page. Now that would bring to view the entire decision tree. So we are starting out with node 1 here, which is the root node, and we have training set and validation set. What is the prior probability? Okay. Non-event is 90.43%, event is 9.5% for training, and this is validation set. Now, at this point, okay, the computations that we did for just 2 predictors, now SAS is going to do that computation for all the predictors that we've included, and then select the one that has the least amount. In this case, we don't know whether it used Gini index or entropy or the log work. Okay, we'll talk about that in just a second. But whatever criteria that was used, based on that, a split was selected, and which was this. So 98.5, this is income, 98.5, less than 98.5, and any missing cases where we're in this left side node, and the right side node was greater than or equal to 98.5, and here this node has no further splits. So this is it. So we have a very good separation. Like the purity is reasonably good, actually as a matter of fact, very good. So the darkness of the background color indicates how pure the leaf node is. Okay, so here are the leaf nodes. Okay, so the darker the color, the purer the node is. So here this one is 100%. So this is the maximum purity, and there are 13 records here. Okay, and this one is also maximum purity. Now this one is not that pure, so you have 90, so it's kind of light. So this one is darker than that, so then you see that it is 99%. It's almost like 100%. So here again it's slightly lighter. Okay, this one is really very light, and you see that the impurity is quite high. 35% 0, and 64% event 1. So now a new record comes in, right? Then you go through this tree for the purpose of classification. So you start from here, so you look at the income. If the new record, if the income for the new record is say 100,000, right? Then you go this side. Okay. If it was 50,000, then that's it. You would stop and classify that record as what? 0 or 1. What would your classification be? You come in, the income is 50,000, you go here and you classify the record as 0 or 1 for personal loan. Rami.
For personal loan, 0.
Why?
Because 0 is 99%.
Exactly. Our cutoff point, the default cutoff point is 50%. So that's why. So now if it is $100,000, then you go this side. Now you are not done now, because you have further branching to do. Next is education. You will have to now look at what the value of education is for the new record, right? If it is 2 or missing, you go less than 2 or missing, you'll go here. If it is greater than, I think there are 3 values possible for education, 1, 2, and 3. So if it is 2 or 3, then you will branch to this side. Okay?
I have a question. Why was it darker again?
Because purity. So the purity is between 0 and, well, let me back up. Purity is measured by the Gini index, and which is like a node is considered pure if all the records belong to one class. In a binary situation like here, okay, if all of them are 0 or if all of them are 1, then it is pure. Okay. If there is a mix, then it is slightly impure, and the most impure would be like if it is 50-50, then it is most impure. So here 35% to 64% zeros and ones, so that's impure, actually pretty close to 50-50. So you see it's very, very light. Whereas here it's 100% 1. So this is completely pure. And here it is almost 100% 0. Again, very pure. Got it? Okay, so